In this video, we are going to explore how we can use shader graph to create cool looking scene transitions. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. For this tutorial, I will be using Unity 2021.2.7 with the Universal Render Pipeline installed and the shader graph, of course. So I have in my project settings in the graphics assigned the Universal Render Pipeline asset with the 2D render. Now this is only because I want to use the shader graph functionality. I have a simple 2D shoot 'em up game, and when I press start in the menu I go to the first level and I want to create some sort of a transition to make it a bit more appealing. So if I go to my level 1, what I can do, the simplest transition that I can create is go to my canvas, right click, select UI, select image, and I can create an image. I can use in the inspector direct transform anchor preset, hold shift and alt to place set the pivot and set the position, and select the option from the bottom right corner to fill in the whole screen with my image. Now the image is at the bottom of my canvas, that is in the screen space overlay, so it is filling up the whole screen, and the simplest thing to do to create this simple transition would be for me to use the color and reduce the alpha value to create this transition, this fade out transition of this image to go to my screen. Now we of course need to disable the raycast target so that we do not have any issues with clicking on objects in our game, but this is the way to go with this sort of a simple transition. So what we can do is go to our assets, right click, create a new folder, and I will create shader folder, and we are going to create a custom shader here. So let's right click, create, and I'm going to select at the top shader graph URP, so Universal Render Pipeline, and I will select the sprite unlit shader graph, and let me call it scene transition shader. Okay, now to open our shader graph, double tap on it and a new window should appear. Let's right click on this new window at the top at the tab of it, and let's select maximize so that you can see it in the full screen. Make sure that in the top right corner you have this blackboard, graph inspector and main preview enabled, and you can extend the main preview. First transition that we are going to create will be this expanding circle with the UI sliding down. Now in our shader, to use this shader with the UI element, we need to add in the shader graph blackboard, select this plus icon and select texture 2D, and we need to call it main with capital M text, because our image will want to pass to our shader or to our material the main texture using this underscore main text reference. So we need to have this in case we want to use this texture for our transition. We are not going to use it, but this is required for the image. So next we are going to actually create in this main area of our shader graph some nodes. This is the node editor where we can actually do some work with our shader. So let's right click, create our spacebar and select or type UV. Now UVs are the coordinates of a texture that we want to place on our objects. If we output the UV as a base color of our fragment, we are going to see that now our main preview, so this is the preview of the object, how it will look like using the shader, will have those colors, the same colors that our UV. So what is going on here is that UV are represented by value 0 to 1, and this is actually a vector 2, so x and y value, with the 0, 0 point at the bottom left corner, and with the 1, 1 point in the top right corner. Now, if you are not sure about the UV node or about shaders in Unity, Jetali has created the Unity Shader Bible, and I am using this to learn about shaders myself, so I can really recommend this book. The link will be in the description of this video. Now, since we do not have any texture for our image, this is just the map of values from 0 to 1 on X and on Y. But what we can do with it is we can drag this output 4, which is a vector 4, to another node called the distance. So let's type distance. And you can type, select A, so A is the input field, so the first input field. Now, as I have already mentioned, the point 0, 0 is in the bottom left corner, but with the distance node we can offset it. So let's right click here, create, and let's say vector 2, because we want to move it by a vector 2 offset, and we are going to pass 0.5 and 0.5 on X and on Y. Now if we drag the output to the distance as the B input, you are going to see that now we have moved this point to the center of our image, of our preview. So now in the center of our image we have value 0, 0, and to the corners we have values 1, 1. So this will mean that we have this circular pattern here. What we can do is select all of those nodes by simply holding the left mouse button and selecting those, move them a bit. And now we can drag output and let's type step. And we want to select step input. So step node actually binarizes our input values. So this will mean that we are going to get either 0 on one value depending on what we pass here as what we set in this edge field. Now since those values are from 0 to 1, if we type 0, so this means that the output of the step node will be 1 for each pixel representing our object. If we drag this value, we're going to see that there is a circle growing out of the center point. So this is the circle that we have created using the distance node. And we are going to see that it grows up until value 1, where the black color fills in the preview. So black color means that value is 0. And if we use the step node as the input for our alpha value, so the transparency, we're going to achieve this version of our transition that we are going to grow from the black screen. We are going to grow a dot from the center of the screen, where here are going to appear our images from our level, and until it reaches 1, then the image will be simply transparent. So this is our first transition. Now to be able to use it through the script, we are going to create in the blackboard, use plus icon and create a float value. We're going to call it progress. Now make sure that if you select it in the graph inspector, you are going to see that the reference value is _progress. We are going to use it through the script. Drag this progress value and assign it to your edge input for the step. And I'm going to select this progress, and I'm going to select in the node settings in the graph inspector, let's select mode to be a slider from 0 to 1, so we can slide it inside the material preview. So now this is it. We can of course assign a specific color to use instead of a black color, or when we are having this output of the step node as full white, we are going to use this color passed here. So we can create in the graph in the blackboard another variable. Let's select our color, and we are going to pass here scene or transition color. Since I'm not going to use the texture from it, I'm going to select this, drag it, and I'm going to pass it as the input for our fragment to be the base color of our image if the step node is outputting values 1. So now if we select at the top left corner save asset and right click on this tab of our shader and let's unmaximize this, we're going to be able to right click on this, create a material. And right now our material will be changing the color based on our transition color, so we can set it to be red, or I will set it to be something like purple or violet. And we can select this progress and we can slide it, and as you can see our preview is disappearing. There is a hole here because we are setting the transparency of this material using this progress. So now let's go back to our scene view, and our image is white, but it is inside the canvas, which is in the screen space overlay. If we try to select this image and assign the material to our new material, we are going to see that it doesn't actually work. We can select our material, and right now with the progress set to 0, everything is violet. But now if we try dragging our slider, we are going to see that while it works in the scene view, in the game view it doesn't. And I do believe that this is a bug of the canvas setting, that if our render mode canvas of the canvas is screen space overlay, the shader transparency will not work. So we need to deal with this, and to deal with this, what we need to do is delete this image, and we need to, in the hierarchy, select this plus icon UI and create a new canvas. Now in this canvas we are going to select render mode, and instead of overlay we are going to use camera. We're going to assign the main camera here in the camera field. We're going to select the plane distance and set it to be 1. And we are going to select the canvas scaler. We're going to select the scale with screen size. We need to type 1920 by 1080. And now we are going to select this canvas, right click or select this plus icon UI. And we are going to select the image. Okay. And now if we go to the scene view and select this 2D, and select this image and select F to slide to see this image, we are going to see that this image is somewhere here while the camera is there. So we need to select our image, select direct transform in the inspector, select this anchor preset, Alt-Shift and select fill in the full screen. And now our camera is displaying our canvas behind the canvas that is in screen space overlay. So this is a bit of a problem, but right now what we can do is assign to our image our material, so the shader material, and we are going to see that we can display our scene view by sliding our progress bar, so there is no issue with the transparency this way. Now, to make it work with our scene when it is loaded, let's select our shader folder, and here let's create a new script. Create a C# script. Let's call it scene transition. And let's open it up. Great. Let me paste the code for this script. So what we are going to need here is the serialized field private material screen transition material. This will be the reference thanks to which we are going to be able to modify the progress value of the shader. We are going to have a serialized field private float transition time, which will allow us to set the duration of our animation time. So in 1 second we are going to transition from the fully opaque screen to fully transparent using our shader. Here we are going to define the serialized field private string property name _progress. Now if you select our shader inside Unity, at the bottom you will see that there are properties and one of those is _progress. This value we want to access through this string name. Okay, now next thing we are going to have is a public Unity event on transition done. So right click on this Unity event, quick actions and import Unity engine.events library. It will appear at the top. Now this will be the event that will inform us when the transition was done, so we can start dropping the UI for our game towards the screen of our game, so that we can hide it at the start when we are transitioning using this screen space camera mode of the canvas. Now if the shaders will work with the screen space overlay, we wouldn't need this, but we now need to hide our UI to make it look a bit better. And we're going to have a private void start method, which will start a coroutine, transition coroutine. You can right click on this quick actions and generate this, and this will be generated with a wrong return value. Set it to be private enumerator transition coroutine. Now in this coroutine we are going to set the float current time value to be 0, while current time is less than transition time, so this is the delay of the length of our animation. We're going to add current time plus equals delta time. We're going to set our screen transition material, so the reference from the above. Set float, we're going to pass the property name, so _progress string, and we are going to pass here a mathf.clamp. We're going to clamp the value between 0 and 1, current time divided by the transition time. And we want to yield return null. So this will be the coroutine, and when we are done with this, we are going to call onTransitionDone?invoke. So question mark simply means that we are going to check if some method is assigned to this event to be called, and if it is, we are going to call it. Okay, let's file and save this script, and we're going to go back to Unity. Okay, in our level, we are going to, or our scene, we are going to create a new game object scene transition. And I'm going to drag here our script. Well, let me reset the transform just in case. And we need to assign here the material, so the reference to our new material. The transition time will be the length of our animation, and the property name needs to be the same as we have defined in our shader. So now what will happen is we are going to set the value of our progress value to be 1 at the start of our level, and we are going to gradually increase it throughout the 1 second period to be 1. And if it is 1, this will be transparent. So if our image has the raycast target unchecked, this is pretty important to uncheck this raycast target. So now if I go to my main scene game, save my current scene, and if I press play, you will see that if I press start, we are going to have this transition at the start of my game, but the UI will be still visible. To deal with this, I can go back to my level 1, I can go back to my shader folder just to keep everything in one folder, and I'm going to right click, create here a C# script UI transition. And this will be a script responsible for dropping my UI element from above the screen towards the correct position. So what I can do is select my canvas. I can select my main menu, select it, and go back to my 2D view in the scene view, and I will simply move it using the move tool above my screen. So it is outside of the area of my screen, and I will go to my script. Great. And I will paste the code here. So what are we going to have here is the reference to private rect transform, private float transition time. Again, this will be the length of the movement of my UI element, and I will have two values, serialized field vector to start position, and we can add here the end position after the comma. So now in the awake, private void awake, I will create start position equals rect transform anchored position. And actually we are not going to use this end position. We are going to have a public void show UI method that we are going to call from our event, start coroutine, show coroutine. Again, right click here, quick actions, and generate this method, and just change the return value to be I enumerator. And we are going to use the same code that we have used previously, so we are going to create the current time float equals 0. We're going to set rect transform, and to move our UI we need to use anchored position equals vector3 lerp start position, and vector30 is this is the end position, and we're going to use mathf.clamp01 current time divided by the transition time, and we're going to return null here. Let me save the script. Let's go back to Unity. Okay, let me select my main panel, so this panel that is anchored, and I'm going to simply assign here our new script, so UI transition, and I will select the main panel as the rect transform target. Transition time, let me set it to be 0.5 maybe, and the start position is just exposed for me to see if this is correct. Now I will select my scene transition and select in the on transition done, select this plus icon to add an event. I will assign the main panel, select the function, UI transition, and then we have this show UI. Now if I start my game, okay, let me press start. And as you can see, my UI has slid from above towards the correct position, and there was the screen transition at the start. Great, so let me show you what else can we create using our shaders. Let's select our shader, click Ctrl D to duplicate it. It will be given the index 1. Let's open this shader up. We're going to right click and maximize this. Okay, and we have our previous structure of the shader. Now the second transition will be this sort of triangles disappearing in our game. So we want to use posterize node, so let's type posterize, and posterize node will simply create this mosaic effect. We're going to right click or spacebar create vector2, because I need to set this to some value. This will be the value 30 and 30, and this will be how many of those squares we are going to create. So this will create this effect of this UV image being pixelated. Now to use this, we are going to use something else, so we're going to drag this output to the polar coordinates. And we should have polar coordinates, and we are going to select UV. So this will be the input of my polar coordinates. So again, this is pixelated. Now, polar coordinates are simply coordinates that defines the point as the distance from this center point and as the angle from the specific direction. Now, we do not necessarily need to focus on those, but what we can do is split the output. So let's drag it and let's type split, and we are going to see that it outputs 4 different values. Now, if we drag this R and select preview node, we are going to see that we have exactly the same circle. But if we output the G value, so preview, we're going to see that we have the same image as we had with this polar coordinates, but now it is in black and white. Now the values here will be, since this is black, this means that those values are negative, while those are positive. And this means that if we select multiply node and multiply it by 4, this will mean that we still have the same image, but now we are going to multiply each of those values by 4. So if this was -1 or -2, this will be -8 now. So what we can do now with this, if we drag this output to the fraction node, we're going to get only the fraction part, so -2 to -1. We are going to get only the fraction portion, -1 to 0, only fraction portion, creating those 4 rectangles that are the gradients going from this point towards the next point. So this is black and this is white. Now, why this is useful, you ask? Well, what we can do is, instead of this distance node, we can pass this as the input of our step node, and depending on the progress value, we can create those pixelated triangles that disappear. So this is great, because now if we save this asset and go back to our material, what we can do is at the top of our material, we can select our shader graph, and we should have our shader transition, scene transition shader 1. And now we should be able to see that we can perform this transition using our new shader, creating those triangles. So let me show you the last one shader that we want to create. So let's select our scene transition shader 1, and let's Ctrl D to duplicate it. Now this should have index 2. Let's open this up. Let's maximize this. Great. And we are going to delete most of the nodes. Only we are going to leave the UVs and the step node, because now what we are going to do is repeat the distance node. And we are going to create again vector 2, so we should probably copy the scene transitions default shader. Okay, so now we are going to offset this, and what we can do is multiply this. So if we multiply this, we know that this is between 0 and 1, so now we are going to multiply it by, for example, 2, so this will be from 0 to 2. So now the white is much more prominent, so the white area. Now what we can do is we can use another node called simple noise, which creates as a noise values. If we set the X to be something low, so for example 50, we're going to have this less granular noise. If we now multiply those two, we can multiply two textures or two values to connect them together. So we have this very dark area in the center, and around we have those random noise values. Now if we pass this to our step node, we're going to see that our progress value at 0 is this is covered. If we drag it a bit, we're going to see that from the center we are going to have this pattern of something like a paper burning or something like this, up until value 1, where this will disappear and this will become transparent. So again, if we save this shader, let's right click, unmaximize this, let's select our material, select the shader. We can select our shader graph and select scene transition 2, and now we will see that we have this shader using this noise instead of our previous transition. So now if I go and press play, since we have been using the same material, this will work with our current script. Great! So now you know how we can use shaders to create different screen transitions. If you have enjoyed this video, leave a like, leave a comment, subscribe to the channel, and I will see you in the next video. Take care!